Welcome, my dear students. This is a very important video where you will learn about the methods of determination of equivalent weight. Means how to calculate equivalent weight of different substances like metal, especially like metal. Alright, so here we have different techniques to calculate equivalent weight of metals. So in this category, the very first method is hydrogen displacement method. This method is useful for determining equivalent weight of those metals which react with acids and displace hydrogen. This is the most important fact which you are supposed to keep in the mind. That is why I have written here so that you can pause the video and read it once again. Alright, so which are those metals? In this list, we know sodium, potassium, zinc, magnesium, etc. According to the activity series, all those metals which are above hydrogen, alright, their equivalent masses can be calculated using hydrogen displacement method. Why? Because these metals can displace hydrogen from acids. Alright, though we have direct formula, but I believe in knowing the technique of developing formula. So I have written the formula, but I would like to explain that how this formula can be derived. So in this method, what is done? A particular known mass of a metal. Suppose we have a metal M and its mass is suppose x gram. Alright, x gram, a known mass of a metal is made to react with acid, excess of any acid, dilute acid like dilute HCl, dilute H2SO4. Alright, so that metal can displace hydrogen from the acid. I hope it is clear. Now, volume of this hydrogen liberated at STP is calculated, and accordingly its mass is also calculated. Suppose the hydrogen which is liberated at STP with the x gram, alright, its volume is V, small v, and this V ml of hydrogen gas which is liberated at STP has volume y gram. I hope it is clear. Alright, now let us derive the formula. Now how this formula can be derived? See here. Y gram of hydrogen is displaced by x gram metal. Alright, so 1.008 gram hydrogen will be displaced by x upon y into 1.008, alright, or you can simply consider 1. So x upon y gram. I hope it is clear. This way the first formula is being derived. X upon y. What is x? X is mass of metal. See here. What is y? Y is mass of hydrogen gas which is liberated at STP. Alright. Now we can have a different way of this formula as well. In place of mass of hydrogen displaced, we can write here volume in ml of hydrogen liberated at NTP. How this formula can be derived? Let's have a look. Alright. See, dear students, try to understand how the formula based on volume can be derived. See, y gram means y gram of hydrogen has volume V ml at STP. So I can say V ml at STP of hydrogen is displaced by x gram metal. Alright, so I hope it is clear. Now, the standard mass of hydrogen taken is 1.008 gram, and we know one thing very well. I'll write here that 2 gram hydrogen at STP is equals to 22400 ml. Alright, this relation we know very well. So 1 gram of hydrogen at STP will be 11200 ml. So that we are supposed to write now here, because we are taking standard to calculate equivalent mass. What is the standard of hydrogen? 1.008. So 1.008 gram hydrogen will have volume at STP how much? 11,200 ml. I hope this calculation is clear to you. So I can say 11,200 ml at STP of hydrogen will be liberated by X upon V into 11,200. Now this is the formula here. What is X? X is mass of metal. What is V? V is volume in ml of hydrogen liberated at NTP, alright, multiplied by 11,200. So this way we derive the formula. So dear students, you can solve the numericals based on hydrogen displacement method using directly the formula or using this unitary method calculation. I hope this method is understood. Now dear students, we have the second method. What is the second method? Oxide Formation Method to calculate equivalent mass of metals. Alright, now let us see the how this method is, this formula is derived, or on which fact this method is based upon. In this method, you know what is done? Metal is converted, suppose M is metal. It is converted into its oxide either by reacting directly with oxygen, alright, or by converting metal into its nitrate, MnO3 whole A. A is the valency of metal. Alright, we don't know what is the valency of metal, so I am writing A. And then heating the nitrate. On heating nitrate, we know metal changes into its oxide, except sodium and potassium. This method is not applicable for sodium and potassium. Okay? Because their nitrates convert into their nitrites. Similarly, this method also is not applicable to calculate equivalent mass of silver and mercury, because their nitrates decompose into metals. So on these four metals, this method is not applicable. This is very, very important point to keep in the mind. Rest all the metals can be converted into their nitrates, and these nitrates on heating change into metallic oxides. Now metallic oxide, I'll write the formula M2OA. What is A here? Valency of metal. Alright. Now, then through this we can calculate. Suppose we have X gram of metal. Alright, X gram of metal we have taken. Now with this X gram of metal, how much oxide is combined? That we can deduct the mass of oxide with the mass of metal. Suppose Y is the mass of metal oxide. So mass of oxygen will be equals to Y minus X gram. I hope it is clear. Same thing will be applicable here, whether you convert directly or you convert indirectly. Same way we can write. Alright, here also oxide formula will be M2OA, because valency of metal is unknown, so considering it A, M2OA. I hope it is clear. Alright, now let us correlate and generate the formula. Now, see here. We can say that Y minus X gram oxygen combines with X gram metal. I hope it is clear. Now for calculating equivalent mass, what is the standard mass of oxygen is taken? That is 8 grams. So 8 gram oxygen combines with X upon Y minus X multiplied by 8. Now what is X? X is mass of metal. What is Y minus X? Y minus X is mass of oxygen multiplied by 8. So this way the formula is derived. I hope it is clear to you. Now let us see how can we correlate it with the volume. Alright, see here. Now let us assume that Y minus X gram oxygen at STP occupies small v ml volume. Alright, clear? So let's derive now. Now see here. Now I'll write VML, not Y minus X gram. Now VML oxygen combines with X gram metal at NTP. Alright, clear? Now see, oxygen's O2 What is the mass of O2? That is 32 gram. So 32 gram at STP is equals to 22,400 ml. So 8 gram of, because here we are taking standard weight of oxygen to calculate equivalent mass is 8 grams. So 8 gram of oxygen at STP will be how much? I hope you can calculate 22,400 upon 32 multiply by 8. 8 fours are 32, so that will be equals to 5,600. Alright, so 5,600 ml oxygen will combine with X upon V into 5,600. Alright, what is X? X is mass of metal. What is V? V is the volume in ml of oxygen at STP multiplied by 5,600. I hope this formula is also understood by all of you. Now third is chloride formation method. Alright, and the formula is equivalent weight of metal is equals to mass of metal upon mass of chlorine multiplied by 35.5. In terms of volume, mass of metal, volume of chlorine at NTP multiplied by 11,200. This is also based on the same logic which we have applied on the first and the second method. Now here in this method, suppose metal M is there. First of all, the most important thing, this method is used to calculate the equivalent mass of such metals which cannot displace hydrogen from acids. Alright, so here we can comfortably calculate the equivalent mass of metals like silver, platinum, mercury, gold, alright, copper, such kind of metals. Alright, so here in this technique, this metal is made to react with directly chlorine. Now suppose valency of metal is A, so MClA. Clear? Or first this metal is converted into its nitrate, MnO3 whole A. You understand A is the valency of metal. And then this metal nitrate, by reacting it with HCl, is converted into its chloride MClA, either directly or indirectly. The meaning is same. Now suppose we have X gram of metal and MClA. Mass is how much? Y gram. Alright, so same way, exactly same technique. Now mass of chlorine will be how much? Mass of chlorine will be Y minus X. We understand, no? So Y minus X gram chlorine combines with X gram metal. Now how much is the standard value taken for chlorine to calculate equivalent mass? That is 35.5 parts. So 35.5 gram chlorine combines with X upon Y minus X multiplied by 35.5. See, same. X is mass of metal, Y minus X is mass of chlorine multiplied by 35.5 gram. Now suppose this Y minus X gram has volume V ml at STP. Now 35.5 gram will have how much volume at STP? Now we know 71 gram, that is the molecular mass of Cl2, has volume 22,400 ml. So 35.5 will have 11,200 ml. So now in place of 35.5 gram, this step I am changing now. If I write, alright, I'll write once again. Now see, if I write V ml chlorine at NTP combines with X gram metal. Alright, so 35.5 gram chlorine is equivalent to 11,200 ml at STP. So 11,200 ml chlorine at NTP will be equals to X upon V into 11,200. So X is mass of metal, V is volume of chlorine at NTP multiplied by 11,200. Now moving on to the next method, that is fourth method, that is metal displacement method. Metal displacement method is used, it is based on the principle that more reactive metal can displace the less reactive metal from the salt solution. So this technique is also based on the knowledge of the activity series. So here I take one example. Suppose I take example of iron reacting with copper sulfate Here iron displaces copper and results in the formation of FeSO4 plus copper. So here iron is the metal added, this is the metal added, and copper is the metal displaced. Alright, now if W gram, see the ratio of the mass of iron metal added is to ratio of the mass of metal displaced, means they have a particular ratio. Since they have a particular ratio, and also 1 gram equivalent of metal added is equals to 1 gram equivalent of metal displaced. So it is based on this fact we can write this ratio in the form of formula, that mass of metal added upon mass of metal displaced is equals to equivalent mass of metal added upon equivalent mass of metal displaced. So here if I apply this formula on this equation, so I can say here mass of Fe upon mass of copper, because Fe is metal added and copper is metal displaced, will be equals to equivalent weight of Fe upon equivalent weight of copper. Alright, so this way we can apply the method onto such kind of reactions. Now the next method is double decomposition method. This method is used for such kind of metals the salt of which undergo double decomposition reaction. Now here I have taken for an example one imaginary salt. So imaginary salt AB and CD, alright, and they both exchange their radicals. On exchanging their radicals, AD is precipitated and CB is formed. Alright, so for the salts which undergo double decomposition method, such metals their equivalent mass can be calculated using this method. Now here the mass of AB will have a ratio with the mass of AD. Similarly, 1 gram equivalent of AB will be in ratio with 1 gram equivalent of AD. So its equivalent mass will be in ratio with equivalent mass of AD. So this ratio we'll write in the form of formula. So I can say mass of AB upon mass of AD is equals to equivalent mass of AB upon equivalent mass of AD. Up equivalent mass of AD will be equals to equivalent mass of A plus equivalent mass of B. Definitely for a compound, if there is a compound AB, its equivalent mass will be definitely equals to the equivalent mass of its components. So here equivalent mass of A plus equivalent mass of B together compose equivalent mass of AB. So we can write equivalent mass of A plus equivalent mass of B upon, in place of equivalent mass of AD, we can write equivalent mass of A plus equivalent mass of D. So this way this technique can be applied to calculate equivalent mass of such metals the salt of which can undergo double decomposition reaction, especially which kind of double decomposition reaction? Precipitation reaction. Alright, precipitation reaction. So these methods are, I hope, clear to all of you. Dear students, there is one more method. The name of the method surely I'll share with you all. The name of the method is electrolytic method. Alright, so this is the sixth method, electrolytic method. This method I will teach you in the next video. Alright, because before teaching you this method, you should be familiar with the Faraday's law of electrolysis. So after teaching you those laws, I will teach you this method to calculate equivalent mass of metals.